Hey, so welcome to the video. Today we're going to take a look at how to do a repeated one-way ANOVA on SPSS. So we're going to use this test when we have a categorical within groups variable and when we have a continuous dependent variable. We're also going to take a look at how to check the assumptions of this test and how to report those. We'll take a look at how to report the results of the test itself in APA style, and we'll take a look at how to create a graph for this test. So for this example, we're going to imagine that we're looking at the scores that students achieved on different exams. So in this file here, we have percentages, and we're going to imagine that we're interested in what the students did the night before their exam. So in this case, they went out for dinner, and these are the scores for their exam the next day. In this case, they had an early night, and these are their scores for their exams after having an early night, and the same thing here. So they went out for drinks on the third occasion, and these are the scores that they achieved after going out for drinks one night. So let's first take a look at how to put these data into SPSS. So when we have a within subjects variable or a within groups variable, when we go to variable view, so we'll use this tab at the bottom, we're going to use separate rows to represent each one of those levels of the independent variable. So what's the first one? So the first one is dinner. So let's write dinner in the top cell in this name column. We'll write early night in the cell below that. And we're going to use something like an underscore because we can't actually use a space in this column. And then finally, in the third row down, we're going to enter drinks. And then we just need to tell SPSS, using this measure column over here, that these data are continuous. So we're going to select this scale option for each of these three rows. Once we've done that, we can go to data view, and we can see that dinner, early night, and drinks have appeared at the top of these three columns. So that corresponds to the columns we have in this Excel file. So I'm just going to copy the data from this Excel file and paste it into these three columns that we've created. So one of the assumptions of the within groups one-way ANOVA is that the data are normally distributed within each one of the conditions. So to check this, we can go to Analyze, then down to Descriptive Statistics, then across to Explore, and then we can transfer all of these variables into the dependent list box, all of these levels of the variable, I should say more accurately. So I've transferred those across to the dependent list box. I'm then going to go to plots, and that opens this Explore Plots window. I'm going to untick stem and leaf because I don't think it's very helpful. I will tick histogram, and I will tick normality plots for tests. So we'll go to continue, and then we'll go to OK. So in this output, I'm just going to scroll down a little bit, and this is divided into two sections. So we have one type of test here, and we have another type of test here. Typically, this one on the left is used when you have a larger sample of maybe 50 participants or more, or 50 data points. And typically this one on the right is used if you have a smaller sample. And since we have just 10 participants, and 30 data points in total, I'm going to focus on this Shapiro-Wilk side of the table. And specifically what we're looking for is whether or not the value in the SIG column is above or below 0.05. And if it's above 0.05, it indicates that the data in that condition are normally distributed. And if it's below 0.05, it suggests that the data in that condition are not normally distributed. So in the case of our example data, we can see that in every single row we have a value above 0.05, indicating that the data are normally distributed in all three of these conditions. So now that we've checked that assumption, we can run the test itself. So to do this, we'll go to Analyze, we'll go to General Linear Model, then we'll go to Repeated Measures, and the number of levels box is highlighted straight away. We have three levels in our variable. We have dinner, early nights, and drinks. So I'm going to enter 3 into this box. You can leave this as factor 1 if you want, but you might want to give it a more descriptive name if it helps you to interpret the output. So I'll call it something like pre pre-exam activity. And I'm just using underscores in this box because I don't think you can use spaces. So pre_exam_activity. Then I'll click add, and then I'll go to define. Okay, next I'm just going to transfer all of my levels of the independent variable into these three spaces here. So I've just highlighted them all. I'm going to transfer those over. Next, I'm going to go to options, and I'm going to ask for descriptive statistics and estimates of effect size. Then I'll go to continue. Lastly, I'll go to EM means, and I'm going to transfer pre-exam activity to the display means for box. I think I need to tick compare main effects, and then there are a few options here. I'm going to choose one for only, just because it's quite a commonly used option. So I'll go to continue and then to OK. So we can see, if we look at this means box, we can see that we have some different means between each of these conditions. So in the dinner condition, the average percentage in the exam was 57. For the early night condition, it was 61, and for the drinks condition, it was 53. So we can use the within groups one-way ANOVA to determine whether the pre-exam activity had a significant effect on exam performance. So to do that, I'm going to look at this multivariate test box, and it actually runs several sort of related tests. So you can actually choose which one you refer to. I'm going to refer to the Wilks-Lambert row because this is the most commonly referred to row. And the most interesting thing, as usual, is the sig value, which you can actually see doesn't differ between these different rows in this case. And we have a value of 0.001, and because that's less than 0.05, we can conclude that there is a significant effect of the independent variable on the dependent variable. But that itself isn't particularly interesting because we don't know whether there was a significant difference between the dinner condition compared to the early night condition compared to the drinks condition, etc. To gain some insights into that, we can scroll down a little bit, specifically this pairwise comparisons table. So we can see we've got 1, 2, and 3 here, and those will correspond to the order in which we entered the variables in the box that came up when we went to analyze, we went to general linear model, we went to repeated measures, etc. And then we transferred the variables over. We can actually see that dinner has a 1 here, early night has a 2 here, and drinks has a 3 here. And in this table we have 1, 2, and 3, so 1 equals dinner, etc. So we can use this to tell whether there are significant differences between the specific levels within our independent variable. So we've got 1 and 2 in this row here, and we can see that there's a sig value of 0.085. So that indicates that there wasn't a significant difference between the dinner and the early night condition. If we look at this bit here, so 1 compared to 3, we have a sig value of 0.867. So again, we have a value above 0.05, so no significant difference between the dinner and drinks conditions. However, if we look at 2 versus 3, so this is early night versus drinks, we do have a value below 0.05 because we have a value of 0.005, indicating that there is a significant difference between those conditions. So let's take a look at how we can report all of these results that we've generated. So firstly, I would start off by reporting the results of the normality test. So I've said Shapiro-Wilk tests indicated that the data were normally distributed in the dinner condition, the early night condition, and the drinks condition. And I've inserted some statistics here, so let's take a look at where those statistics come from. So we need to go back to our outputs, and we'll go up to this tests of normality table. So let's look at the dinner row first, and we're focusing on this right side of the table, so the Shapiro-Wilk side of the table. In the statistic column, in the first row, we have a value of 0.954, and that corresponds to this value here, so W equals 0.95. So as per APA style, I've just rounded that value to 2 decimal places. In the brackets here, we have a 10. That just comes from the degrees of freedom column. We can see that that's the same in all of these different rows. And if we focus again on the dinner row, we have a sig value of 0.715. So we can see here, P equals 0.715. And then we just have the same statistics repeated again for the early night condition and for the drinks condition. So that's the results of the normality tests reported. So let's take a look at how to report the results of the ANOVA itself. So I've said a one-way ANOVA, a one-way within participants analysis of variance, aka an ANOVA, was conducted to investigate the impact of pre-exam activity on exam results. So I'm just saying was conducted to investigate the impact of the independent variable on the dependent variable. Then I said there was a significant effect of pre-exam activity on exam results. Wilks lambda equals 0.17. So let's take a look at where that comes from. So we're going to be scrolling back down through this output until we get to the multivariate test table. And that first value I showed you of 0.17 is from this Wilks lambda row and from this values column. So I've just rounded 0.165 up to 0.17. So that's first value. Wilks lambda equals 0.17, F equals 20.24. So again, we're focusing on the same row. We've got an F value here. That's been rounded to 2 decimal places. We have these 2 degrees of freedom here, 2 and 8. These are what appear in parentheses here, 2 and 8. We have a p-value of 0.001. So I've said p equals 0.001. That corresponds to this value in the sig column. And then finally, we have a partial eta squared effect size statistic. So 0.835. And that's what we have here, rounded to 2 decimal places. So that's the results of the one-way ANOVA reported. Let's also take a look at how to report the results of those follow-up tests. So specifically, we did Bonferroni corrections. So I've said here that a post-hoc analysis with Bonferroni corrections indicated that there were no significant differences in exam results between the dinner and early night conditions, or between the dinner and drinks conditions. However, exam results were significantly higher in the early night condition compared to the drinks condition. So let's take a look at where these values are coming from. So we've got means and standard deviations here. So here I'm referring to the dinner condition. If we'll go back to the outputs, we can see that the mean for the dinner condition is 57.20 and the standard deviation is 15.01, which would be rounded to 15.02 in APA style. And that corresponds to what we have here. And then I've just done the same thing for the other conditions. So the means and standard deviations for the early night condition and the means and standard deviation for the drinks condition. I've also just reported the p-value that corresponds to the difference we're referring to. So here we're referring to the difference between the dinner and the early night condition, and we've got p equals 0.085. So dinner and early nights, if we go back to the SPSS output, and if we look at the pairwise comparisons table, we have a value of 0.085 in this row that corresponds to 1 and 2, and as we saw before, 1 and 2 correspond to the dinner and early night conditions. And then I've just done the same thing for these p-values that appear here as well. So finally, let's take a look at how to create a graph to represent these results. So to do this, I'm going to go to Graphs, then Charts Builder. I'm going to look at this list here. Normally bar is selected as the default, and that's what we'll create for this. I'm going to drag this simple bar option up to here. You can also just double click on it if that's easier. And then I'm going to transfer dinner to this y-axis box. And then I'll transfer early night. And that comes up with this create summary group dialog box, which you can just close by clicking OK. And then finally, I'll transfer drinks over as well. If you want to have error bars, you can go to this option here and select display error bars. It's quite common to have 95% confidence interval error bars. So I'm just going to leave this option checked, and then I'll go to OK. As you can see, the graph that SPSS creates for you as a default isn't especially aesthetic. So what I would do, just to make it a little bit easier on the eye, is double click on it, which opens this chart editor. And then you can do various things. For example, if you want to get rid of certain aspects, for instance, I would probably get rid of this thing at the top because I would prefer to create my own title. So I'll just right click on that and click delete. And then I might do the same thing for this note down here. I would prefer to create that note myself within a Word file. So I'll just right click on that and go to delete. And with respect to the bars, you can double click on them and that will open this properties window. Some things you might want to change are the color. For example, if you're producing a report that has to be an APA style, typically graphs need to use grayscale colors. So I wouldn't use blue, but I might choose one of these gray options on the right over here. So I'll just click on one of those colors. I'll click apply, that changes the color. Something else you might want to change is the width of the bars, because these look very wide at the moment. So I'll go to bar options and then maybe just play around with this number a bit. So I've just moved this over to the left, then I'll click apply, and I think that looks much better. So I'll just close this. And then if you want to change anything else, you can just click on it. So I just did a single click on that, and this looks a bit small. So, well, you can change the font if you like to. And you can change the size to make it a bit clearer. So let's choose something like 18. And yeah, that's much easier to read like that. So any changes you do make here will be saved automatically. So we can just go to this close button straight away. So I'll just click on that. And we can see that those changes have been saved in the output. So let's just take a look at how to present this graph within the report. So I've got a formatted version of this graph here. In APA style, we have figure 1, or whichever number it is, in bold and not italics, no sort of punctuation after. Below, we've got a title that's in italics but isn't in bold, and it uses title case. So that just means that every first letter is capitalized, with the exception of prepositions and articles, basically. So don't capitalize words like in and the and, but we do have a capital at the start of the other words. And finally, I just have a note below the table, below the graph, to specify that the error bars show 95% confidence intervals. So that's about it for the within groups one-way ANOVA. I hope the video was helpful. If there was anything I didn't cover or anything was confusing, let me know in a comment and I'll try to get back to you. Thanks a lot for watching. See you next time.